Students, in case of rules for tracing images found by spherical lens, right? The first rule is take convex lens as well as concave lens simultaneously. So when the light ray is falling parallel to the principal axis like this, then after refraction it passes through the focus on other side. See guys, in the spherical mirrors, a reflection phenomena will take place, whereas in the lens, all the time refraction will take place. That's why here, after refraction, the light ray bends and passes through the second focus. In rule 1, guys, when the light ray is falling parallel to the principal axis, right? And almost, guys, this rule is similar to the concave mirror first rule. But in case of concave mirror first rule, after reflection, the light ray passes through the focus on the same side like this, students. But here, it is going like this from the second focus. And if you see the same thing for concave lens, the light ray falling parallel to the concave lens, it gets diverged. And if you extend the diverged ray, then it meets at the focus. So this is a rule 1 for the convex lens and concave lens. In the rule 1, we took the incident light parallel to the principal axis, just like convex mirror and concave mirror. Right? This is refracted light you take. This is also refracted light, not reflected. Refraction will take place in case of lens. Understood, guys? So this is the first rule, and let's focus on the second rule. If you take the second rule here, the light ray passing through the focus after refraction becomes parallel to the principal axis. Same like concave mirror rule 2. I repeat, students, light ray passing through the first principal focus after refraction becomes parallel to the principal axis. Here also the same thing, students. The light ray appears that it is coming from F2, second focus. After refraction, it passes parallel to the principal axis. That's it, students. The emergent ray is parallel to principal axis. Here also emergent ray is parallel to principal axis. But by nature, it is converging lens and it is diverging lens. The rule 2 is also very important. And in the rule 3, guys, very important rule for drawing the ray diagrams. And in this rule, students, the light ray goes undeviated or without any deviation across the optic center. For convex lens as well as for concave lens, guys, when the light ray is passing across the optic center, it goes undeviated. Very important rule, students. And almost in all ray diagrams, we will prefer to use this third rule, because with the help of third rule, image tracing becomes simple and easy. Okay, guys. So in the mirror or in spherical mirrors, we have 4 rules. But whereas here in the lenses, you are having only 3 standard rules for image formation. Let us see the image formation by the convex lens, right? Here when the object is kept at infinity, guys, the light rays appears to be parallel from infinite object, and after refraction, they must pass through the second focus like this. Then for object at infinity, in this case also image is formed at the focus, but relative to mirror, guys, image forms on the same side, but here image forms on the other side. In lens, usually refraction will take place. So this is the image. And here, students, again, nature of image will be inverted. Okay, guys, nature of image will be inverted. That's why we will treat the nature of the image here as real inverted, right? And magnification will be negative, very smaller one, like this you will be getting. And listen, this case is quite similar to the first case of concave mirror. And if you take the second situation when the object is kept beyond 2f, beyond 2f is nothing but first center of curvature, right? And this is the second center of curvature of this curved surface, right, students? When object is kept like this, then the image is found between center of curvature and f2 of the uh, convex lens. Okay, students, almost the procedure is same, but in case of concave mirror, reflection will take place, but here refraction will take place, due to which the image is formed on the other side of the lens. Whereas in case of concave mirror, image is formed are the same side, right students? So here first case object at infinity, this is object beyond to F1 or center of curvature of this curved surface. Why we are having C1 and C2 means for this curved surface, right? C2 is the center of curvature. For this curved surface, C1 is the center of curvature. I repeat, students. For the second curved surface, C1 is the center of curvature. For this first curved surface, C2 is the center of curvature. And in case of length, students, there is no standard rule that compulsory the radii of curvature must be same. R1 and R2 for a given convex lens may or may not be same, right? So it may or may not be same. That's why here we have taken C1 as center of curvature of this R2, this one, and C2 as center of curvature of this. Fine, students. Next, here in this next situation, object is kept at 2F, to F1. Image is formed at again to F2, that is the 2F on the other side. And here nature of image will not be magnified. That means here magnification will be 1 minus 1, just like concave mirror, guys. But in the case of concave mirror, object and image will coincide with same size. Here size will be same, but object and image will be on either sides. That is at 2F1. If you take object, you will be getting image at 2F2. So this is the 1, 2, 3rd situation, friends. And in the fourth case, when the object is kept between 2F1 and F1, then you will be getting image beyond 2F2. Exactly, you can compare with the concave mirror and you can analyze it easily, right students? Object is between 2F1 and F1, then image will form somewhere beyond C2. Next students, when object is kept at focus, no doubt 100% image must form at infinity. Listen guys, when object is kept at focus, image must be formed at infinity. That's why see guys, the refracted rays are going parallel. They never meet. See, one light ray from the object is going like this across the focus and one more across the optic center. It goes undeviated and both are parallel. This parallel indicates that the light rays are not going to meet anywhere. Therefore, image formed will be infinity. Similarly, when the object is kept between focus and pole, like the students, AB is the object, then just like in concave mirror, here also this is a special case where a virtual image is formed. In all the first 6 cases, real inverted, but in this case, virtual image is formed, but highly magnified image will be formed. Only this is a case where magnification is positive, right? That is, magnification will be greater than +1. Magnification comes out to be a positive value, but greater than +1, right, students? So these are the 6 cases, right? Now, all the 6 cases can be understood with the help of this tabular form. For the convex lens, which is quite similar to concave mirror, at infinity, you can expect image at second focus, highly diminished, real and inverted, right, students? And in the second case, beyond to F1, then between F2 and 2F2, F1 is the first focus, F2 is the second focus, diminished. At 2F1 and 2F2, equal size. And at F1 and this one beyond to F2, enlarged. At focus F1 at infinity, highly enlarged. Between F1 and O, enlarged, virtual and erect. And just like guys, here in the first 5 cases, magnification comes out to be negative. But this is the 6th case where magnification comes out to be positive. So this tabular form exactly comparable to the image formation for concave mirror. Now, if you take concave lens, guys, the behavior of concave lens is identical and similar to the behavior of convex mirror. Here, by nature, concave lens is a diverging lens. And on comparing with convex mirror, guys, you can expect only 2 different positions where image is formed. First one is object at infinity. Second one is object between infinity and optic center. When the object at infinity, the light rays from the object appears that they are coming parallel to each other. And after refraction, they get diverged. If you extend the refracted rays, here you will be getting the image. That means for infinite object, all the time you will expect image at focus. Suppose if you take the extended object kept between infinity and optical center, then in this case, after refraction, right, you will expect that virtual image is forming between F1 and O. Every time, as long as the object between infinity and optical center, image is expected between F1 and O. So in case of concave lens, we will be having only two situations for understanding the image formation. See, highly diminished and diminished, virtual and direct, and magnification always like this you will take +1, or else magnification will be less than +1. There is no case where you will be getting enlarged image in case of concave lens.